Great. So now let's come to the solution that I have built. So in the solution that I have built, I have 4 packages here. The first package is the front layer, which is the API layer or controller layer, whatever you call it. This is a layer where the request first lands. Then there is exceptions package, which is actually holding all the exceptions. Then there is model package, which is holding all the model classes or the entity classes that you call in LLD. Then there are some providers, and then there are the services. So let's start with the deep dive in model. So as this is a movie ticket booking application, so there are some entities which will definitely come to your mind when you think about the problem, right? And those entities are like movie, screen, theater, booking, and those kind of things should definitely come to your mind. And that's what I have also created in my design. So the model has movie, and movie will have a name, movie will have an ID. I could have included more things like a movie could have an actor, movie could have a genre, and those kind of things, but I did not include it, and I just mentioned other metadata because that is not expected from LLD. The main idea is like you should create more entity classes and good relationship among them. It's not required that you create all the attributes of a particular thing, because you have time crunch also in your interviews, right? So just mention like just mention the most important things, which is the name and ID, and just mention other metadata, like there can be other things. Similarly, let's say there will be a theater. A theater will again have a name and ID, and theater will have a screens. A single theater can have multiple screens, because let's say PVR will have multiple Audis, right? Audi 1, Audi 2, Audi 3. So similarly here also a theater can have multiple screens. Now let's come to screen. A screen again will have an ID and a name, and screen will be for a theater, and screen will have multiple seats, right? A screen has all the rows of seats that you see in a single screen, right? So those list of seats will be there. Now, what is a seat? A seat is just an ID, and it has a row number and a seat number. So it's a grid, right? And when you go for a movie, there's a grid of seats, right? So that's why we are using row number and seat number for the seat. Now we have a show. A show is something which is run for a movie, right? And in a single screen. That's what we just read in the problem statement. So that's what exactly is mapped over here in its entity class or its model class. So a show will have an ID, and a show will have a movie for which the show has been scheduled. Show will have a screen, like on which screen it has been scheduled, what is the time of show, and what is the duration of show. So you can see like whatever we discussed in the problem statement, that exactly mapping is created over here. And actually that's how you should proceed or approach your LLD problem. Whenever you are creating model classes for your LLD, try to replicate that with the actual behaviors. Like if the movie booking is there in and let's say you have to book a movie, and you have to create a system. So try to map physical entities directly with the entity classes that you are creating here. So let's say we have a show here, right? So show will have an ID, movie, screen, start time, and duration. So that's what we will have in a normal scenario, like in a day-to-day life when you go for a movie, when you go for a movie show. So that's what we have mapped over here. If you go by this way, then you will not have to think about, okay, what is owned by what. Just try to map it with real scenario. Like in real scenario, okay, show has a movie, a show has a screen, and show has a start time. So just map it like that in your model classes. So this way it will be really easy for you to map all the model classes, not for only this problem, for any problem that you do for LLD. Now there will be a booking class. A booking, again, let's say, just mapping it to a real scenario. A booking will have an ID. A booking will have a show, like for which the booking has been done, what seats have been booked in the booking, right? And which user has booked the booking. Then there will be a status, like whether the booking is confirmed, booking is created in state, or booking is expired. So a booking can have status also. Booking can have transaction ID and all those kind of things also, but I have not included them because I am not including the payment flows in my system. I am including a bit of them, but not the overall flows of payments, because that I have kept it as an improvement or further things that you can do in this design. Great. Now let's see some of the behaviors of these model classes. So let's say a booking booking can be created, and booking can tell whether it is confirmed or not. A booking can be confirmed, a booking can be expired. So you can see a booking can never be explicitly created, right? Because booking is created whenever the constructor is called. That's when we are calling it as created. So that's why we are not having an explicit method for created. We just have two methods, which is confirm and expire. And similarly, you can see a created booking can only go to confirm booking, right? A confirm booking cannot again go to confirm booking. Similarly, an expired booking cannot go to confirm booking. That's why we have a check over here. Like if the booking is created, then only move it to confirm. If the booking is not in the created state and you're trying to confirm it, then it's an invalid state. You are not allowed to do that. Similarly for expired booking. Now for movie, there's no behavior required as such, so we have not created it. Similarly for screen, we just create a screen and then we have a behavior method to add a seat to the screen, right? Then we have show, right? Then we have a seat. A seat can have a row number, a seat number, and an ID. Then we have a show, and show will again have a movie and a booking, right? Movie screen, start time, duration. There is no behavior associated with it. Then we have a theater. Theater can add a screen and it can be created. So these are basic behaviors for theater. There is one more model class which I have not put directly into model package, but this is again a sort of a model class. I have put it into providers. I think I should move into model 2. Let's refactor it. Great. So it's in the model 2 now. So model class SeatLock is actually providing a particular lock for the seat. You will get to know about it in detail a bit later, like what this actually represents. But to give you a basic idea, this actually represents the seats which are temporarily locked by the user. So when the booking starts, we lock the seat temporarily for a user, right? So we are using a model object for it, and that is called a seat lock. So it's a lock for a seat, right? So whenever user starts a booking, we lock the seat for that user, right? For that show. So that's what we are mapping over here. Seat lock is actually representing a lock on a seat. So since it is representing a lock on a seat, so it definitely has a seat for which show it is being locked, because a single screen or single seat, because a seat is on a screen, right? And a screen can be used for multiple shows. So for which specific show the seat has been locked, that we have to map. So that is being done over here. Now, what is the timeout in seconds, right? Like till what time that lock is valid. This I have done for this bonus requirement. If you remember, right? So bonus requirement asked me to have some mechanism to include the expiration of locks if the user, or the expiration of blocked seats if the user does not continue with the payment, right? So that expiration is handled by timeout here. Now the lock time tells at what time the seat was locked, and locked by is again the user, like who locked the seat. Now there's a behavior method associated with it, which is lock expired. Is lock expired tells whether the particular lock is already expired or not. So this is a basic behavior or the model classes that you have, and their attributes and their behaviors. Now let's start with how the overall flow happens. So first of all, the call comes to controllers, right? So let's say there is a booking controller, there are movie controller, there are payments controller, there are show controllers, and there are theater controllers. Some controllers are actually user facing, and some controllers will be just for the admin purposes. So for example, theater controller has methods like create theater, create a screen in theater, and create a seat in theater, right? If you can see, these are the three methods over here. So these methods are not going to be used directly by the user, right? Because these methods are more of like admin purpose, like whenever a new theater is being added, so those methods will be called over here. So that's why there is a theater controller, which is allowing you to create theaters. It is also allowing you to create a screen in a theater. It is also allowing you to create a seat in a screen. You could argue that in my whole design I have created single theater as a logical thing, which is handling all the things like theater, screen, and seat. You could argue like this is not good, and we should create three separate classes for theater, screen, and seat. But let's discuss this, why I have done this way when I discuss the solid principles, right? Why I have made those design choices. I will be discussing it later. Okay, so now the call comes to create theater. Theater service gets called, and theater service will create the theater. Let's see how it works. Create theater will take the theater name. It will create a theater ID, and it will create the theater object. It will put it in the theaters, and it is using in-memory maps because we are not expected to create DBs. The theater is created and it gets returned. Where it's gone, yeah, it gets returned. Similarly for I have done it for everything, like for screens and seats. So let's start from the beginning. For creation methods, I've already discussed create theater. These are create screen in a theater. So it takes screen name and it takes a theater. So it creates a screen and it adds the screen in the theater and it just returns the screen. Right? Similarly, we have a method for create seat in a screen. It again creates a seat by creating its seat ID. It creates a seat by getting its row number and seat number from the input. Then it stores the seat in its memory. It adds the seat in the screen and then it just returns the seat back to the user, whoever called it. There is a helper method which is just to create a screen object. So that's all. And there are some getters like to get the seat by its ID, to get the theater by its ID, and to get the screen by its ID. So they are mostly CRUD operations being handled by the service to create something and to get something, and those somethings are related to theater. And theater controller, as you can see, for each of these API methods or controller methods, it is just calling the service methods to create those things. Now there are show controller. So again, show controller just create the show. So there are two methods. One method is actually again an admin type of method, which is like admin will create a show for a movie. Second method is like getting available seats for a show. So we have like users will be fetching what all seats are available for a particular show. So they will giving a show ID and we have to return all the list of seat IDs, like what all seats are available. So that's why we are having this get available seats method in the show controller. Let's see how this works. So we get a show ID in the input. Show ID, by the show ID we get the actual show object, like what is the show for the show ID, and we use show service for that. Then we call the availability service. There is something called availability service, and availability service gives us the available seats for that particular show. Now let's see how this availability service is implemented. So get this availability service is actually taking all the seats for these screens, right? So what are the available seats in general? So just if you again think about it, what are the available seats? Then available seats are the seats, like all the seats that are there on the screen except the seats which are unavailable. And unavailable seats could be either logged or booked. Logged seats are ones for which the booking has started but not yet completed. And booked and permanently unavailable seats are those which are already booked and payment is completed, right? So that's what exactly we have done here. So for the available seats, we just take all the seats first back from the screen, then we fetch all the unavailable seats. I'll go to the unavailable seats implementation in a bit. Then we say available seats are all the seats and we'll remove unavailable seats from it and we just return the response. Now unavailable seats, we just ask the booking service to give us all the booked seats, right? So booking service is maintaining a list of all the bookings, and all the bookings have, and each booking has what all seats are booked in that particular booking, right? So so we just call booking service to give us back all the booked seats. Now there is something interesting called SeatLock Provider. SeatLock Provider is, as the name suggests, it is providing the functionality for locking a seat. So SeatLock Provider, we ask to give all the locked seats for that particular show. We'll go into detail of how the SeatLock Provider works when we actually lock the seat, but let's assume for now like there is something called SeatLock Provider which is actually providing the functionality to lock the seats temporarily, because we have to again, I'm highlighting or saying these things again and again because this is really important in this design. Like there are two types of blocking. One is temporarily block, one is permanently block. Permanently block is here when the seat is actually booked. The temporary block is when the seat is only locked, and that happens when the booking just starts and the payment is not yet completed. Right, so we'll discuss this SeatLock Provider in detail later on. But as I told you, unavailable seats are the combination of both. So we first get the booked seats and we just add the locked seats into that array and we just return it. So these are our all unavailable seats. So that's how we get available seat, all seats minus unavailable seats, right? So these are available seats and we just return it to the user. So that's how show controller is written, and we get all the available seats and we just map, we just get the IDs of it and we just return it back to the user. Now let's see the booking controller, because now this is the interesting piece, which is actually creating the booking where all the locking and all will happen. But before that, let's just see one more admin kind of controller, which is a create movie controller. It is just like a theater controller kind of thing, which is just providing us a functionality to create a particular movie, and it will just call movie service to create the booking. So create movie is again just checking movie name, it is creating an ID and it is just creating the movie and it is storing it the movie in its own storage, right? Now let's come to booking controller, which is the crucial part of it. Now booking controller is actually taking a user ID, and it is just providing a method for create booking, and that create booking method is taking a user ID, it is taking a show ID, like for which show the booking has to be done, and what seats the user has selected. So this is just to create a booking, this is not confirm booking, right? So this is like a starter booking kind of a method. So we get these details, we get the specific show object, then we get the seat, we map seat IDs to seat objects, and then we ask the booking service to create that particular booking. Now let's see how the create booking method is implemented. We go to create booking method and we say we again get user ID, the show, and the seats for which this booking has been done. Booking has to be started or booking has to be created. We just first of all check right, is any seat already booked, right? If the seats that the user has selected, they are already booked, then we cannot allow the booking to continue or booking to be created, right? So that's one thing. Second thing is seat cannot also be locked. So we will check both, but let's see how we are checking that. So first of all, we are checking this, the seat should not be already booked. So we if the seat is already booked, if any seat is already booked, then we just throw the exception that seat is already permanently unavailable. And to check is the seat is already booked, we get all the booked seats for this show, and we check if the seats with the user has selected is in the booked seats. If any seat with the user has selected is in the booked seats, then we just return true, which means the seat in the input is already booked. So we just throw the seat permanently unavailable exception. Now once we once we are sure that the seat that we have got in the input is not already booked, then what we have to do, we have to lock the seats, right? So that no other booking can use the same seats. So that's what we are doing here. So we just try to lock the seats. Now we go to the lock provider. Lock provider is an interface because it is there can be different, it is giving us the flexibility so that there can be different types of lock providers. A lock provider can be using Redis, a lock provider can be using actual DB, lock provider can be just in memory lock provider, that like the one we have used in our example, because we cannot use Redis and all right now, but we are keeping it flexible so that tomorrow if Redis we need, we can just replace the lock provider implementation. So let's go to the lock provider implementation. So locked seats say that we take all the seats and it checks first if the seat is already logged or not. If the seat is already logged, that means the seat is temporarily unavailable. So first of all, we checked the seat should not be booked for the booking that we are creating. Then now we are checking the seat should not be already locked. If the seat is not already locked, then we are just locking the seat. The seat lock, it just create the lock object, the seat lock object that we discussed. Let me just show you that. So the lock seat, it is storing it. So the locks are stored in memory in the so the SeatLock provider that we are using it's an in-memory SeatLock provider, and it is storing all the locks in the memory. So that's why we are just using a map over here. And as I told you, we are using a lock timeout, which was a bonus feature. We are taking the lock timeout as a dependency of this provider, and it will just use the lock timeout in the SeatLock. So let's see how the SeatLock is created. So when the SeatLock is created, it just checks whether the whether we have a list or a map actually for the particular show in the input or not. That this is just to ensure we have this map for a particular show, right? For this one map, right? So because we have to store the locks per show, so it is actually telling us like what all seats are mapped for the particular show, right? And then it is telling what all seats are locked here, right? So that's why they are two level mapping. So first of all, we ensure there is a hash map for the show, and then we just create a seat lock, and just we then create a we put the seat lock into the show for that particular seat. And when we are creating the seat lock, we are passing that seat, we are passing that show, we are passing the timeout when the lock should expire, which is this timeout actually we got in the input as I just showed you. Then we are putting the time as a current time for the lock time, because right now we are just locking the seat, and then we are putting the user who is locking the seat, right? Great. So that's how we lock the seat. Where is the one? Yeah, lock the seat, right? So let's go back to its usage. So we were using it in create booking part. So create booking, we lock the seats. Then we know the seats have been locked, so we just create the booking now. So we create a booking ID. we create a new booking for the booking ID, for the user ID and seats. We just fill in all those details in the constructor, and we store the booking in our memory, and we just return the new booking. Now I've just put this to do for my reminder, like, do we need to create the timer for the booking expiry? So what is happening is, like, booking are always remaining in created state. We are not ever putting the bookings into expired state when the booking is expired. So that's why I have put a to do. So this is like a further improvement which you can do, but this is not harming our design or functionality so far right now. Okay, so that's how the create booking works. So create booking just create the booking, it returns the booking back to the controller, and controller returns the booking ID back to the user. Now let's see the payments, right? Let's see the confirmation flow. So let's say when the booking is created, and let's say when the booking is confirmed. So when the booking is confirmed, we get the payment success method, and we at that time we confirm the booking. So confirm booking method actually has to do a couple of things. Confirm booking will take the booking, like which booking has to be confirmed, and the user for which the booking is, for who is actually calling the API, right? So we get these two things in the input, the booking ID and the user, and we get the booking object from the booking ID, and we pass it to the booking service. So confirm booking will get booking, the actual full booking, and the user who is calling the service, right? Is it gone? Right, so confirm booking is here. So if the booking in the user and the user who is trying to confirm the booking are not same, then that's a bad request exception, right? So we are just doing bad request. If now we have to confirm the booking, right? So for that we have to first check whether we are still holding the lock for that booking, right? It might have happened that the timeout has already gone, so the lock has expired, and someone else might have got the lock. So we cannot allow to confirm the booking now, because the seats are no more locked by that particular user. That can be the use case, right? So we have to first check whether the seats are still locked for the particular user or not. So we are providing a validate lock method on the lock provider. So validate lock method actually it tells you whether the lock is valid or not. So it just checks that if the seat is locked. If the seat is locked, then the seat should have been locked for that particular user only, right? So that's how we are validating the lock. If the lock is valid, then that means the seat is still locked by the current user. So we do not throw bad request exception. But if the validated lock throw false, that means the lock is no more valid for this booking for this user. So we just throw bad request exception. And if the locks are valid and we are good with the confirmation, so we just confirm the booking. We just move the booking into the confirmed state. Now let's see what happens when the payment fails, right? So when the payment fails, we process. We call process payment failed on the payment service, right? There is a payment service that we have created, and payment service takes allowed retries, like how many times the retries are allowed. So again, first of all, for the payment processing failure, we are checking whether the bookings user is the same user or not, who is booked. Actually, the calling user is the same user who has booked who has actually made the booking or not. So if that's not the case, then we are just throwing exception. Then we are checking, have we exhausted the failure count or not. If we have exhausted the failure count, then we unlock the seats. If we have not yet exhausted the failure count, allowed failure count actually, then we do not unlock the seats, because still the user has those seats locked, so we cannot unlock the seats, right? But if the user has already completed the maximum number of failures, right, so that at that time we just unlock the seats. So we are again maintaining the failure count in memory, in a map, and the payment service is handling that. So whenever there is a booking failure, we just increase the number of failures, the current failures, and we just put them into the memory. And if the new failures that we have got are already maximum than the allowed retries, then we unlock the seats. Now let's see how the unlock happens. Unlock again is implemented by SeatLock Provider, and SeatLock Provider will unlock the seats, and it will just validate again it can happen, right? The payment again can fail after the expiry or timeout, right? So we again have to first check whether still the lock is there with the current user, and if the lock is there with the current user, then only unlock the seat. If the lock is already with another user, then don't do anything, because you cannot throw an exception. There is no point throwing an exception, because you just you do not want to fail the request. You can just free the seats, and that's all you can do. So unlock seat will just remove the seat from the particular show. Great. Now, I did not show you how we get all the locked seats, right, in the beginning that I told you. So if I show you SeatLock Provider, so SeatLock Provider we already discussed lock seats, unlock seats, and validate lock, but I did not show you get locked seats for a show. So get locked seats, it just sorry, this is a usage. We were using an unavailable seats, so get locked seats for a show. It just gets all the seat locks, right, and it just return all the locked seats from those seat locked, right. And before returning, we check whether the seat is still locked or not. So that means the that actually tells, like, checks whether the lock should not have been expired. So this is actually checking it. The seat lock can be expired also, right? So we are checking give me all the seats which are locked, and these are not expired also. So we are checking that via is seat lock method. So when we are returning all the locked seats, we are checking whether the seat is still locked or not. If the seat is still locked, then only add it to the locked seats and return that full array back from the get locked seats method. Awesome. So this is all, I guess. This is all the functionality that we have returned. We have created multiple controllers, which is allowing us create booking, which is allowing us creating a movie, which is allowing us confirming booking, and failing a booking, failing a payment, we can say. And then there is a show controller, which is again allowing us to create a show, which is allowing us to get all the available seats for a show. Then there is a theater controller, which is again admin kind of a controller, which is allowing us to create theater screens and seats. There are some exceptions which I discussed, along the way I was discussing the solution. So each exception is used for that purpose, and we also discussed all the services, during the flows that we discussed. So booking service I have created for handling all the booking flows. It is handling create booking, get booked seats, and all those kind of things. Movie booking is handling all the movie flows. Similarly, payment booking, similarly seat availability. I already showed you seat availability in detail, right? So similarly, we have created all the services.